I don't feel anything at this bearing. I can feel a little bit of thumping going on there. Turn the right one. I got a clunk clunk. Very good fit. A little bit of a rumble there. Very good fit. That's definitely got problems. There is some clunking here. Same size on both sides. So there is not an up and a down. Bearing.
It's a 3/4 inch U channel. Is this going to do you?
This will fit right in there.
Alright. So then we've got a possibility.
We got a possibility.
Is that the way you want to do it? You want to push that down through?
Yeah.
How far are we going to have to continue to push?
Well, this is going to taper right here.
Quick.
So what do we got? Half an inch?
Right. So you're good. Right. You want to do one, or are you going to video them both? That way you can say, okay, now this is how you really do it.
So we'll see how it goes here. It's tight now.
You want a heat source on there? Fire a heat gun and make it a little bit warmer, but I mean, I'm not talking about a torch or anything. But
yeah, I got a little bit of a bow in it now. What it's doing is kind of
collapsing. I can fire up a heat gun and maybe heat will make it expand, will it not?
make the bearing rates expand. That's what's holding this up right now. This is a 6-ton hydraulic. That baby's got some pressure. Get some of this heavy gauge metal and then cut a circle out of it where those two pieces would slide right together.
What I want here is this gets pretty hot. Because you have some pressure on it now.
I got some pressure, yeah.
So chances are, when that heats up, you'll go.
I don't know if you can't hang on to it. It didn't take me long to set that temperature.
What's in here? 140, you get up 180, 200, it's probably going to just relax. Moving?
Well, I got half a pump out of it, so I think it's slow bump. There it is.
He turned it loose.
You got some tongs to pick it up with?
I got channel locks up.
And there should be a oil seal. Yep, there's an oil seal. So a new oil seal, because this bugger was leaking. And that's all part of, that's welded. That's welded in, so okay, so that don't move.
So, now you know how to set up and do your other one.
Good center. So I can mic this other one that we had to heat up and see it could be just a fraction.
All you got to do is freeze the shaft and have this at room temperature, or maybe a little warmer. I don't know how warm you want to make it. That's 3/8. The numbers go which direction?
There's the numbers. So I'm going to take these apart. I'm going to have to knock that spacer out, move the balls over to one side and drop them out, and it was making that rumble. Inner axle sequence, you got the C-clip, the bearing, oil seal. This is a retainers, RETAINERS 162-113-12. Okay, what I got here is both of the inner drive shafts. This is the left. Right side. And the spline. Get these two together. These look like they're the same. So, is it the way it was machined? Or has the inner drive shaft been replaced by one out of another vehicle? These are just how they are left and right. For this one to be wore out like that on that side, the gear would be turning counterclockwise, reverse, to turn it this direction. This one, the way it's worn, it's only beat up on this one side. The other side isn't. So this one acts like the gear is forcing it to turn forward. Alright, another mystery. What's causing that wear? You can see there's a lip here, so you're not going to press that seal out backwards. You're going to have to press it to the outside. And of course this part is welded in place. Okay, to take that oil seal out, I'm using a 1 7/8 socket. I'm pressing it out down, and that fits. And a 1 inch on top, and that covers just inside. This machine surface has got a little bit of a burr from the machining, like over sharpening a knife. So I'm going to take my file, and it looks good. I'm ready to put on the new seal. And that oil seal number, this is a CHO 14558, dipped in Viton. Installing I got a little bit of oil on cloth. It's going to lightly lubricate the inside of the oil cavity and the oil seal itself. So the oil seal is going to be preventing the oil coming this way. That's why the direction has to be correct. The open goes to the inside, the closed comes to the outside. You could actually push these in by hand. Yeah, that's a big enough hammer. And she is seated all the way around. The old bearing is 8-ball. The new Japanese bearing, 9-ball. So this one ought to be stronger and have a smoother action. Gotta get the grease out of it. Next shield. Aluminum, you just peel it out. I don't have to go any deeper than just inside. That's all the deeper I gotta go. That's pretty much the difference between a sealed bearing and an open face. Alrighty, we all both learned something today. The bearings are in the oven at 250 degrees, and the inner drive shaft in the freezer at 5 degrees. We're going to try the heat shrink method. Alright, I have just brought this out of the freezer. It's a little frosty. Put some more lube on the oil surface area right here and on the bearing surface. The bearings are hot. Oil seal on first, lubricated both parts. I can just press this on. Okay. Bearings next. Alright, bearing. Okay. And now I've got a 1-inch piece of pipe which fits the race perfectly. I'll press that on first, see if it goes down without a little force. Nope, okay. Almost there. When it gets where it needs to go, it'll be up against the... Okay, she's cooling off pretty quick. I'll put a little oil on it. This here is the same, it looks like, and the gap's the same. Okay. Actually, it'll pull up against the bearing when it mounts into the differential. Last stage is the clips. And the last one, doesn't matter, they are round, and that one clipped. Okay, there's my new bearinged, new oil seal inner drive shafts ready to install. And you know, since the oven was heated up, I'm having pizza. Alright, we're looking at the inside of the bearing. So your 90 weight gear oil is going to be splashing around in here, and that's how it lubricates that bearing. So the bearing is open and it gets the lubrication it needs. Oops.